In my honours year, I was studying a very special neutron star that was orbiting another one. And they were travelling around each other around about 300 kilometres per second. And these stars were very good for testing the general theory of relativity. And in fact, the discoverers went on to win the Nobel Prize for Physics for the discovery of what was called the binary pulsar.
Yep. Because
the binary pulsar's orbit was shrinking by 3 millimetres per 8 hours, and they actually managed to measure that, and that was precisely the rate at which general relativity predicted the orbit should shrink if they were giving off gravitational waves.
Cool.
So really it was the study of general relativity that led me to pulsars, and then when I got to ANU I met a guy called Dick Manchester at the CSIRO, and he was one of the sort of leading pulsar experts in the world, and I did a joint PhD between CSIRO and Mount Stromlo Observatory at ANU.
Fantastic. And then you headed off to work with NASA, then Manchester, where the famous Jodrell Bank is located, then back to Australia with the CSIRO, then Melbourne University, and then to a very young Swinburne University, where you founded the now world-renowned Centre for Astrophysics and Supercomputing. That must have been an exhilarating experience to watch Swinburne graduates and researchers become astrophysics leaders all over the world now. And you're back there as a director now, or did you never leave?
In your introduction, you said I was the founder and director of the Centre for Astrophysics and Supercomputing. That's true, but I stepped down from that position in 2010 and became a Pro-Vice-Chancellor, and then I'm now the director of the National ARC Centre of Excellence for Gravitational Wave Discovery, which is still a part of the Centre for Astrophysics and Supercomputing, but a national one.
Fabulous. Now, let's move on then, Matthew, to your recent magnetar research. You worked with a large team using a great array of instruments to look at a strangely behaving magnetar. How was this team assembled? What instruments were used? And how was the research organised? And what did you discover? And where does that lead us next? A new theoretical model for magnetars? Oh, and you might want to briefly explain what a magnetar is, please, Matthew.
Yeah, so a magnetar is an extremely magnetic neutron star. So we measure magnetic fields in astronomy in a unit called Gauss.
Yep.
A French magnet would be about, 100 Gauss. And when you have a magnet that strong, although it's attracted to iron and so on, you don't notice too many fancy things about it if you grab one and twist it around.
Yep.
Turns out if you make a magnet spin, it doesn't actually like it. And it exerts a torque protesting about that spin. It actually gives off something called magnetic dipole radiation, but it's so weak with sort of the magnets that we're used to that we don't notice it.
Yep.
Magnetars are around about 10 to the 14 Gauss. That's one with 14 zeros after it.
Yep.
And they're very magnetic objects, and the magnetic field seems almost a little bit unstable. So the neutron stars I'm used to studying have magnetic fields of like 10 to the 12 Gauss, maybe a little bit less than that. The millisecond pulsars are only about 10 to the 8 or 10 to the 9 Gauss. So these things are maybe 1 million times more magnetic than what we call a millisecond pulsar.
Yep.
And that seems to give them very different rotational properties to the normal pulsars we see. So one of the things about these magnetars is that they actually change their effective torque by very large factors in a very short space of time. And it makes their rotational history very difficult to track. The other thing they do is that they sometimes just completely disappear on us and we can't see them at all.
Yep.
And so these magnetars have these reawakenings or rebirths. And when they do, we get very excited because you only have a limited window in which to observe these systems before they fade away. It's usually a year or few. Like most new objects that we've only just discovered. There seems to be different classes, and there seems to be some pulsars that become magnetars and then stop again.
That's so cool. Now, recently you were also involved with the discovery of a century, that is, the momentous discovery of gravitational waves. Can you tell us a little about that, please, and tell us about your work with OzGrav and where that research project has led you and your colleagues so far?
Yeah, so OzGrav is a national kind of coalition of 6 universities across Australia. Swinburne's one of those. And many people in Australia are members of what's called the LIGO Scientific Collaboration.
Yep.
There's about 1,000 people around the world that have come together to try and discover gravitational waves.
Yep.
That, of course, happened on the 14th of September 2015. The LIGO Scientific Collaboration uses 2 gravitational wave detectors in the US, one on the east and one on the west coast of the USA.
Yep. And
these detectors look for tremors in the space-time continuum. So if a gravitational wave passes through a detector, causes the arms to get shrunk and stretched, and using quantum optics we can actually detect these deviations in otherwise normal sort of space-time continuum.
Yep. And
if they're correlated between the 2 antennas, then you become more confident that they're real. If they're very, very strongly correlated, you can effectively prove that a gravitational wave has passed through the detector.
Yep.
This first happened back in 2015. It was published in 2016. And luckily for us, it was published just a few months before the ARC was deciding what the next centres of excellence would be. So I was the nominated director for that centre. Certainly wasn't involved in the discovery of the first black holes, but now our university is part of the LIGO Scientific Collaboration. And when the first neutron stars that were merged were discovered by LIGO, we were ready to point our telescopes in the sky to try and catch the cosmic fireworks display that followed.
Excellent. Now, a couple of episodes ago, we spoke with Manisha Kaleb about her work with the Molonglo synthesis telescope. Can you tell us about that instrument and the upgrade you gave it and its new capabilities?
So the Molonglo telescope is actually the largest radio telescope in the Southern Hemisphere at the moment. It's 36,000 square metres of collecting area, but it's got, in some parts, 1960s technology and in other parts 1980s technology. So it's made up of 2 orthogonal arms. They're at right angles to each other. Yep. They're both about a mile long. That's 1,550 metres or so, and about 11 metres wide. And these 2 sort of large parabolic troughs can point at the sky with a beam that's a few degrees wide.
Yep.
And up until, say, 2015 or so, there was no capability to do high time resolution work at the telescope. So our group partnered with University of Sydney and we built them sort of mini supercomputer, which we installed at the site. And this computer processes data from the sky roughly every millisecond.
Yep.
And we search for these mysterious things called fast radio bursts that are occurring in the heavens. These are flashes of radio emission. People don't actually know what causes them yet, although we suspect it's got something to do with either a neutron star or a black hole, because the burst is so short in time. And these flashes seem to occur many thousand times a day. But radio telescopes only look at such a small part of the sky that there's only about 50 that have been found. So Molonglo has an advantage in that it looks at a large amount of the sky and it's got a large collecting area.
Yep.
The receiver technology it's kind of cheap because it has to catch data from so many different parts of the telescope. So there's 352 independent receivers. So it's not sort of super sensitive, but it does look at a large amount of the sky.
Yep.
And it's found 5 fast radio bursts in the last couple of years. And the very latest one, we actually managed to dump the voltages that were being induced in the receiver at the time of the burst.
Yep.
Because we detected it within about a second of it occurring. And so we still had a copy of the raw voltages for the last 10 or 15 seconds in our computer's memory, and we wrote them out to disk, and that enabled us to study the system on microsecond timescales.
Wow.
Which has only ever been possible for one other fast radio burst. It's one called the repeater,
yep.
which is quite a famous one. It's the only one that we know of that repeats. And this fast radio burst showed structure on timescales down to about 40 microseconds. So there's something either in the magnetosphere of the fast radio burst or near the black hole or whatever it is that's forming them that is only something like 40 microseconds in time across. So if you multiply that by the speed of light, you can get the idea that we're talking scales of only a kilometre or few
yep.
that are causing these systems.
Look, while we're on fast radio bursts, what is it that convinced you that they're the real thing?
Yeah, so as you said in your introduction, I worked with Duncan Lorimer and his team in publishing the first one. I was at the Parkes telescope with Duncan, and he showed me some of the hints that they'd detected something interesting, and we were lucky enough to have some tools to be able to look at the data in a different way than Duncan could. And we're very surprised to see such a perfect, what we call sweep of the radio emission from the high frequencies down to the low frequencies.
Yep.
But the Lorimer burst was so incredibly bright that it almost seemed too good to be true. And if you have a very bright object, normally in nature, if you can detect one really bright star, there's usually sort of thousands of faint ones. In nature, very bright things seem to be rare, but you often have large numbers of fainter objects.
Yep.
And just of the way that things are distributed in the universe, if the Lorimer burst was real, we should have been detecting fainter versions of it or analogues of it further away. And our initial attempts to do that all failed.
Yep.
So I was a little bit concerned about the reality of the Lorimer burst. And even more so when one of my students, Sarah Birks-Law, discovered that there was a source of man-made interference near the Parkes telescope, which also showed some of the same characteristics as the Lorimer burst. In the meantime, we'd commissioned a new set of receiver technology by working with our friends at Berkeley, which was sort of perfect for looking for fast radio bursts. And although I might have sort of doubted their reality, we were fortunate that a PhD student at the University of Manchester was searching the results of a new survey that we've done in collaboration with international partners, and we actually found 4 fast radio bursts in the first pass at our new survey's data.
Yep. And
one of them was, again, very bright, but the improvements in technology really made us think that these things must be real. And then I think by the time the repeater came along, there was no doubt they were real.
Absolutely, yep. So one of your specialties now, Professor Bales, is using custom-built supercomputers to create models and simulations and to extract information from huge data sets. Now, this is the face of modern astronomy, and every day almost we're hearing of new instruments like the SKA precursors and FAST coming online that generate mountains of data so quickly that we barely have time to interrogate loops of that data. And we certainly don't appear to have the data warehouses and storage capacity to save it for later use. Now, I'm reminded of the importance of archival data with your work on the Lorimer burst. Do we simply run the risk of losing really valuable data because our algorithms can only find what they're looking for?
Yes, I think that's certainly an issue. The Longitude telescope, for instance, catches 22 gigabytes a second of data.
Yep.
And it's impossible to look at every byte by eye. I don't see it as a problem. I think it's just a new skill set that we're learning. But I am reminded that when we discovered the Lorimer burst, the data processing software that we used actually looked at the Lorimer burst and the fact that it was so bright and decided that it must be interference because nothing that bright should exist in the sky that we didn't already know about.
Yep.
So the Lorimer burst was lucky in that it was in a 13 beam receiver, and its arrival in the main beam of the telescope was so loud that our software decided it must be interference and actually deleted it. But we were lucky enough to pick it up in two of the what we call side lobes, which just got a faint echo of the Lorimer burst, but it was so bright that it was actually a reasonable signal. So I've no doubt that similar things are probably happening today, that we're probably deleting things that are actually interesting, but nobody can complain at the rate of scientific progress, with these new tools. I think that in time we're not going to let too much slip through the net, but we're at a transition between looking at your data by eye and looking at it with computers, and it's just part of the evolution of science, I think.
It is indeed very exciting times. Thanks, Matthew. So what an amazing and wonderful journey. Do you want to tell us about some of the other collaborations you're working on at the moment?
Certainly. So the South Africans have just built a new telescope. It's an official SKA Pathfinder. It's called the Meerkat.
Yep.
It's 64 dishes in the Karoo Desert in the north of South Africa. And it's beautifully engineered. And they have almost all of the 64 dishes working. And I'm part of a collaboration that stretches from South Africa to Australia, over to Europe and the US and Canada. And we're bringing together some of the world's best, what we call pulsar timers, to use this telescope to look at radio pulsars.
Yep.
Now, like most sort of good new bits of technology, it's quite a bit more sensitive than existing telescopes in the Southern Hemisphere. And we think we'll be able to look at over 1,000 pulsars a day using this instrument and study gravity in ways that haven't been possible in the Southern Hemisphere today. So that's an exciting project. We should get our first tranche of official time in the next month or two, and we're just putting together the necessary sort of data processing pipelines and tests to check that system's working the way it should.
Fantastic. Okay. Now, the microphone is all yours now, Matthew, and you have the opportunity to give us your favourite rant or rave about the challenges that we face in science, in education, in equity, in outreach, our quest for knowledge and space, etc. It's all yours.
Okay, thanks, Brendan. Look, I think science is well funded globally. I don't think it's well planned globally. I'm very fortunate that I'm the director of a National Centre of Excellence, and we get 7 years of very generous funding, not only from the Australian Research Council, but also our host universities.
Yep.
And that really allows us to not only plan our science very well, but also to collaborate with people in a non-competitive way. Many scientists around the world have to try and get individual grants or grants in a very big pool, and that's a very competitive and sometimes destructive process. So I'm very fortunate that I don't have to spend a lot of my time applying for money. I know what I'm going to get for the next 7 years.
Yep.
So I think these large-scale investments are very good. They do require people to play nicely together, but I think it really puts the onus for success back on the scientists to attain these very large grants. I really feel sorry for people who early in their career fail to win research funding, because if you get grants early on, you get a bigger team, it's possible to be more productive. If you don't get grants, you often get given more teaching, and it can be a bit of a sort of vicious cycle where you don't produce as much, so next time you apply for a grant, you have even less chance, and you end up with sort of haves and have-not.
Yeah.
So I think enabling our scientists to plan is very important. But I also think scientists have an obligation to tell the public what they're doing with the money, and getting out into the schools and teaching children about the excitement of science, the value of science, and also when our PhD students come out the other end of their PhDs, I'm not a big fan of 100% of them trying to stay in science. I think it's very good for them to take those skills out into the workforce and use the techniques that you use and the discipline behind the scientific discovery and put that to use for industry to generate, if you like, jobs and growth.
Excellent. And yeah, we're calling this golden age of astrophysics at the moment, and what comes from it, there's something new and exciting every day. So thank you, Matthew. And right now we'll warmly invite our listeners to follow at Matthew Bales on Twitter and follow his fabulous journey of discovery. And thank you so much, Professor Matthew Bales.
Okay. Thank you, Brendan O'Brien, for allowing me to play that recording from his Astrophiz website, astrophiz.com. That was episode 56. Apologies for the audio being a little bit hard to understand. It's part and parcel of the fact that Matthew was off his microphone. I think when you're doing digital recordings, digital recording mode, you really need to be on your microphone and no reverb in the room, and that helps a lot. You need to be, the audio level needs to be really good for digital recordings. Otherwise, there's too many artifacts that get brought into it, and it just sort of makes it a little bit harsh on the audio. So, just one of those things, I guess. Anyway, you're tuned to VK3EKH, the official station of the Astronomical Society of Victoria, with the regular Friday night broadcast. My YouTube stream has fallen over once or twice. Apologies for that. Oh, it's streaming again now. You'd have to click on the new live indication to find it. But I think Discord did fall over once, but it bounced back pretty quick. So, again, apologies for that. All right, it's come up to 11 o'clock, so we'll go straight into spaceweather.com. And this is the current disk of the sun. If you were able to see the sun right now with a suitable telescope, and this is the way it would appear to us roughly, with those number of sunspots hitting your eyes, with the appropriate protection, of course. And Russell Ward, yes, at VK3DRW, thank you to who that was that sent that message through. That was Martin. Haven't heard you for a while there, Martin. Thank you for that. DRW Russell. I knew it was Russell. Of course it was Russell. I just completely forgot. Wouldn't it bother you? Solar wind is currently at 745.6 kilometres a second. It's a hurricane at a density of 10.03 protons per cubic centimetre. So it's really happening out there. The current sunspot number is 150. And the radio flux, it's also pretty high at 216 solar flux units, recorded at a wavelength of 10.7 centimeters. And the latest, where are we here? There it is. The latest solar, the auroral glow over the South Pole is looking roughly like this at the moment. So there's still a possibility of seeing some aurora low on the horizon right now, I would say. In fact, let's have a quick look at our, where is it? Our all-sky camera, if I can find it. Don't tell me I closed the page. Hang on, it's sitting in here somewhere, I think. There it is. Okay. So for those watching the TV, that's the current sky up at Heathcote at the Leon Mao Dark Sky site. So there's a bit of a cloud blocking out the moon there. but there's not a whole lot of aurora. You can just make out a small pinkish glow there, but not a whole lot being recorded at this present point in time. It might still arc up later towards the morning. But that's the current sky over Heathcote as we speak. All right, back to spaceweather.com. Interestingly enough, they do report also that there's a strong geomagnetic storm happening now. A geomagnetic storm is underway following the impact of a potent CME on October 10. Storm levels are currently fluctuating between G3 strong and G4 severe. Auroras have appeared in almost every US state as far south as Alabama, Mississippi and Texas, and South California. The light show is still underway, so if it is dark where you live, get away from the city lights and take a look. This is what we've been saying. Interestingly enough, all this activity is also causing some electrical currents to flow in the ground. Now, I know I've reported on this one before. Bring up the step map of the states here. And for those that didn't catch up, first time I mentioned this, electrical currents are flowing through rocks and soil in the United States in response to today's geomagnetic storm. The red zones in this map are from NOAA and show where the geoelectric voltages are the highest. Peak voltages in the US Midwest are near 5 volt per kilometre, more than 100 times normal values when the sun is quiet. Fortunately, today's peaks are only about 25% of what caused the Great Quebec Blackout in 1989. Power outages are therefore unlikely. The map above, the map you see on the screen is a snapshot from a real-time display that takes into account the 3D conductivity of the Earth and ongoing geomagnetic activity. A computer at NOAA's Space Weather Prediction Center crunches the data to produce minute-by-minute estimates of electricity in the ground. These estimates help managers of public utilities safeguard the power grid and keep power flowing to customers even during intense storms. It's an interesting thing that they've got going in the States there to monitor. And of course, once there's a lot of geomagnetic activity, this map just lights up. So it's pretty interesting. We need something like that here in Australia, I think. All right, what's next here? I think that's about it, really. Where's the KP index gone? There it is. The planetary K index. Right now, the KP is equal to 8, and it's considered severe. The 24-hour max KP figure is 8.67, which is also considered a storm activity. And apart from all that, I'll just go back to my camera. vmix just doesn't quite make it easy enough. All right. As of October 11, there were 2,349 potentially hazardous asteroids, and that's as far as I will go on this tonight. There's a few things I was going to squeeze in, but no, not right now. So on that note, we shall thank you very much for listening. I didn't mention my email address tonight. I completely forgot, but I can see that Steve has sent me an email just to give me signal reports on 80. I haven't got the amplifier turned on, actually, Steve. I'm running barefoot, 100 watts, and I haven't raised the tower up, so the dipole is still slouching. You might have noticed some quivering on my audio. I'd be interested to know whether anybody has detected any quivering on the audio. It's not my voice, but it's the effect of the aurora on our ionosphere. I noticed that actually there was a station tuning up an hour or so ago, and on his audio there was distinct quivering as a result of auroral activity on our ionosphere. Interesting observation to hear. Yeah, anyway, enough of that. and let's see, looking at the Discord chat room, we have our resident astronomer David, VK3KDM at the Mount Burnett Observatory. If you want to find out more information about the Mount Burnett Observatory, go to the website, MBO, Mount Burnett Observatory. They meet every Friday night. If the sky is clear, they'll have the telescope open, an old telescope that used to belong to the Monash University. And I'd say that they'd be up there right now, definitely taking in any aurorals, any aurora activity that they can see from up there. And who else is there? Cassiopeia, g'day Nebs. Martin, VK7JAH, we have not heard from you for ages. Bob is there, VK3AZN. He says, good evening, Clint, trusting you are well. And g'day Brett, VK2CBD. I think that's about it there. And that's about it, yes. So there it is. Thank you very much, everybody. We shall conclude tonight's session. But before we do, we shall go across to 80 metres and see if there's any stations wishing to check in for tonight's broadcast. Let me just make sure my pen is working. So I think that's it. I can see my YouTube is working. I'm looking at myself on the mobile phone here. So I know the YouTube is working. There it is. I'm just showing that on the screen. So I'm just monitoring my YouTube feed. I know that's functioning at the moment. All right. This is VK3EKH listening on 3541 kilohertz. Okay, VK3GL, VK3JR, VK3SBX. Anybody else? Okay, now what I have to do, I'll take these headphones out. I don't need the headphones. And I'll bring up my audio from there. So the audio will feed out over the other medium so other people can hear what's going on. Go ahead, Gray, VK3GL, VK3CSJ.
Check-in group VK3GL in Bunyip. Yeah, good evening to you all. Clint, thanks very much for the broadcast. I did notice some quite interesting effects on the audio here on 80 metres this evening. More particularly when you were actually playing that interview and the guy was on the phone. It had some interesting artefacts to it. As much as it was somewhat distorted to listen to on 80 metres on air, it did have some interesting artefacts to it. So yes, I could hear somewhat of some quivering, but I've also heard some interesting fading effects this evening, which is unusual or completely unusual to the normal your normal broadcast where we get the slow fade and that on the signal. That's about it. But this evening was quite different. Good signal generally. At the start of the broadcast was about S9, and as the broadcast went on, it came up to 20 over 9 and seemed to hang around about that level most of the time. Now, just for info, I am going to go back out again and just go and have a look and see whether or not I can see any further auroral activity. As mentioned to you on the phone tonight before the broadcast, that crimson reddy coloured glow in the sky with the naked eye was quite interesting to see for the very first time. Despite my efforts with mobile phone camera, I haven't had any luck whatsoever. However, I've got my old, which is about 5 or 6 years old, might even be longer, HTC. Like at the moment, I've got a Samsung mobile phone, and the camera capabilities are generally quite limited on it, and it doesn't have the qualities to get a long exposure shot or anything like that. But my old HTC, which hasn't got as sharp as camera I think it's only 1.2 megapixel or something. It's not as good as the Samsung in terms of quality, clarity or anything. But this HTC's actually got a facility to do long exposures and also open up the ISO setting to around about 1600 or something. So I went and took a photo just of the sky, which to the naked eye was dark, and this has got a glow on the clouds to it. So I'm thinking that this camera on this old HTC is actually going to be better than my new Samsung phone, and I'm likely to get some sort of a shot from it. So I'm keen to go out for a bit of a drive down the road. It's only a K down the road. Go for a drive down the road and see what we can possibly get on the camera, if anything, because it has clouded over a little bit here since earlier on. Plus, I'm also conscious that the actual current live auroral glow on the Geoscience website has dropped away to what it was earlier on. It was quite predominantly red earlier on, a few hours ago. Before our sunset, it was very red. It had been most of the day, but it looks like it's slowly subsiding. All right, thanks again for the broadcast there, Clint, and we'll catch you up over the weekend, no doubt. VK3 EKH, VK3GL and Bunyip.
No worries, Graham. There's a million little buttons here that I've got to press to get this to work. And there's just a little bit more audio there, I think, for the TV side of it. 1, 2, 3. I think that's enough. Harlow, yep. 1, 2, 1, 2. Yeah. I need somebody in master control to be watching all this and adjusting, so I don't have to worry about it. And I've got my Kiska cat. Kiska? Kiska's in shot there somewhere, just behind me. Kiss, kiss, kiss. All right, that shot of the aurora up there in the corner there's not quite the current one. I just had a quick look at the current image, and it's mostly green now, so the intensity of the aurora is dying off, and actually the most current image is now mostly green, so that red intensity is not there. That was just about an hour ago. I was trying to bring up my all sky camera, but I don't know, the wrong one. I don't know where that's sitting in the scheme of things within vMix. Anyway, note the camera, and yeah, okay. Well, you might be able to use that by the sounds of it. So experiment and have a go at it. Thanks, Graham. Good signal from you too. And note the audio. You said you picked up on a little bit of quivering, I think, during the interview there with Matthew Bales. Interesting. Across to Frank, VK3JR. Good evening, sir. VK3EKH.
VK3JR. Good evening, Clint. And good evening, everyone. Yeah, look, I got a bit of sort of phase distortion rather than quiver on the good professor. And what with the phase distortion and the super reverberance, I found it very hard to copy him, which was such a shame because it was most interesting. It would be really good if Brendan could get these people to come closer to the mic and turn the mic down, and all would be well. Such a shame to have such interesting material kind of go to waste, at least as far as I'm concerned. Never mind. I enjoyed the broadcast, apart from that, and thank you for doing it. Big Aurora is still happening, level severe, still on WWV, and so possibly more to come, as you say. There will be missions, in fact they're on now. I better go and talk. So thanks again for doing it, Clint, and talk hopefully next week. VK3EKH, VK3JR.
Good on you there, Frank. VK3JR, VK3EKH, and I'll go straight across to 160 in a short moment. Say hi to Steve for us too. No worries there, Frank. And I totally agree with what you're saying. It's so important when you're doing an interview, as you say, that's valuable. The knowledge, in this case with Matthew, it's just so important to get that audio right. Somebody said that in this sort of medium where you've got video and audio or for instance a presentation being done by somebody on a stage or up on the screen, if it's being recorded, the audio, the having good audio is probably the most important part of the presentation. The video can be suffering, lack of light or blurriness or double image or something like that. But providing that the audio is spot on, that you can actually hear the clarity perfectly well, it accounts for so much more of the information being understood. So it's the audio side of things is so much more important these days, or not so much these days, but for the video. But it depends. I mean, with presentations, you've got a lot of graphics, and it's important that the graphics be also, understood too. It's a 50 thing, I suppose. Anyway, enough of that. Thanks, Frank. Now it's across to Steve, VK3SPX. By the way, just before I do, David makes the comment that Steve Bentley, VK3YJQ, might have a telluric, is that how you pronounce that? Telluric current detector logging in his backyard. Look, I'll find out about that, David. I know Steve fairly well, and I know he's one for experimenting with things. I know he's got a lightning, a whistle, what do they call it? A whistle detector. No, what's it called? Not a lightning detector. It's not a whistle. It's a whistler. That's what I'm trying to say. A whistler receiver up at Heathcote that runs 24/7, and that's operating in the extremely low frequency part of the spectrum, down around 1 to 8 kilohertz. Listening for whistlers, which there should be an audio stream available on the ASV website that you can tune into. I think that's working. I'm not 100% sure. Have to check with Steve on that one. Across here, Steve. VK3SPX, VK3EKH.
VK3EKH, this is VK3SPX. Yeah, thanks, Clint. No worries. It was good to see Professor Martin Bale get recognition for the discovery of the fast radio burst. And it's really good to see, how much good work that mob at Swinburne is doing. That's really fantastic stuff. I was interested in that map of the United States you had too, with electric currents in the ground. I had a bit of a look. I noticed if there's anything we have that's similar, but that's quite interesting, isn't it? I wonder if you can harvest some of that energy. That was the first thing I thought of. It probably isn't practical, but 5 volts a kilometre or something. Yeah, that's pretty amazing. Now, as far as the aurora is concerned, I got some half-decent images about half an hour before the broadcast. And I was actually keeping an eye on the all-sky camera, which I see you've just brought up during the broadcast. And I thought, well, if I see a whole lot of red there, I'll rush outside. I did go out a few times and took a few pics. It wasn't as good as what it was at the start, but I see there's a little bit of pink there in the bottom left hand there that wasn't there 10 minutes ago. So it might be getting better again, Cliff. So I think I might go outside a few times and see what happens. So could be handy. That's about it. By the way, Graham, look, I've got
I've got a pixel camera here which has got a night mode on it, but I've also got an older Samsung here. It has a thing called hyperlapse. I'd be a bit surprised if that didn't outperform your ancient HTC. Have a look in the more tab in the photos for hyperlapse, and you can take long exposures. All right, that should be about do it, I think, Clint. Thanks for the broadcast, and we'll see you again soon. VK3EKH, this is VK3SPX.
Right. Okay, VK3SPX, VK3EKH returning. Yes, this is the photograph I took about 9:45. It's a little bit hard to see, but Graham, VK3GL, phoned me up and he says, Clint, go outside now. He says, I'm seeing pinks and greens from Upway, not Upway. Oh, brain's not working tonight. Where do you live, Gray? Bunyip, that's it. Yeah, Bunyip sounds like Upway, that's right. Bunyip, out of Gippsland. He was seeing greens and reds. So I went outside and you can see how the clouds were just coming in from the south. But if you look carefully enough, you can see, it depends, on the computer here, you can just see the pink in the sky. I'm looking at the repeater, the audio video coming off the repeater, and it's not that obvious on the mobile phone. I can't really see it on the TV set, but there is some pink there, which I can see on the computer screen, but not on the monitor of the repeater. Anyway, enough of that. So yes, there it is, and you're quite right. Looking at the all sky camera, you can just make out a little bit of pink glow coming in from the south there. So it might just arc up again too. All right. Having said all that, we'll take one more listen on 3541. If there's anybody else wishing to check in, VK3 EKH listening.
1-2, VK3AOB.
G'day, Brett. Have a say.
Very good. Hang on, I'll just get what's happening. I've got the radio playing up a minute. I'd rather that's better. A bit more compression. 1, 2, 3, 4, 5. I'll just get the waterfall up here so I can see what it's doing. Span. Spread it out. 1, 2, 3, 4. 1, 2, 1, 2. There. Okay. That should sound okay there. Yeah, the bit where you're running the stuff off tape, the two chaps talking, and just a bit overdriven. So I was losing a lot of words, which made it spoilt the. Sort of got the gist of the conversation, but it sort of got lost a bit. Anyway, yeah, like you say. Audio is the most important thing when you're recording it to get the level just right. Better to have not quite enough level than too much. Anyway, there you go. Other than that, all was quite good. But back to you.
Thanks, Brett. Good on you. VK3 AOB. Am I right here? Yep. Okay. VK3 AOB, VK3 EKH returning. I totally agree. And a number of recordings that Brendan has done over the time suffers a little bit from the digital artifacts that are present in some of the recordings. If they're not done at the right, speed and conditions. You get a little. I find that if you're off the microphone and perhaps a little bit of reverb in the room, it always works against you. Even if even with communication modes like D-Star and other digital communication modes, if you're not modulating properly, if you're not right on the microphone, or have the audio level right, as soon as you back off the microphone, the digital artifacts that come into the audio is really horrible, and it just makes it harder to read. Anyway, there it is. Okay, we'll try and do better next time. The recording, the ABC recording, I think came across very well. So, yeah. Anyway, all right. Thanks everybody for listening to tonight. It makes it worthwhile, and I can see the glow in the south here from Heathcote is become a little bit more obvious too. I'll just bring it switch across to our all sky cam. In fact, if you look at that, you can actually see almost a curtain stream, if you want to call it that, right near the south part there. Doesn't it look like? I'm pretty sure that's what it looks like. So it might be building up again. Interesting stuff. Okay, this is VK3 EKH on this 11th day of October. Thank you very much, Liv, for listening, everybody, and watching. And sorry about the YouTube stream falling over, but it did come back online again, as did Discord. So for all those watching Discord, some of you have dropped off, but anyway, thanks for making use of Discord. Like I say, Discord is probably the better medium. Just type in Discord, register. There's no money involved. It's just a matter of registering your name and some other information. Once that's been approved as such, then visit my QRZ.com page, VK3EKH, QRZ.com page. And I provide a link. So once you've registered on Discord, if you click on that link, you'll go straight to the ASV chat room, and also the HT stream that I provide, which, like I say, is less than a second behind what you're hearing on 80 meters direct, unlike YouTube, which has got that 60-second delay. But of course, with YouTube, things are recorded, which is the only advantage there. If the YouTube stream doesn't fall over, it's then worthwhile. I can see it's still hanging in though. All right, this is VK3 Echo Kilo Hotel, the official station of the Astronomical Society of Victoria, concluding for tonight. Thank you, everybody, and we'll see you next Friday again to do it all again. So farewell and have a nice weekend and look after yourselves. This is VK3 EKH. Yeah. G'day, Ian. No worries. You're in the logbook. Have a quick save if you like. Go ahead. VK3KKT, VK3EKH. Yep, no worries, Brendan. Sorry, Brendan. Ian, VK3, VK5, KKT, VK3, EKH, getting it all mixed up here. No worries, dear sir. Thank you for calling in. Readability 4 to 5 and about strength 9. Noise level is a little bit high tonight, probably because of the aurora. But I'm hearing the effects of the aurora on some of your signals, so it's very interesting to hear that funny little fading, quivering effect on the audio. It's very, very pronounced. And Britt, when you were doing your testing at about 9:45, I heard you doing some tests around 9:30, 9:45. The fading, the very quick flutter on your audio was very, very obvious really, really obvious to hear. So I hadn't heard it so distinct as on your signal tonight. So it was really interesting. Anyway, thanks, chaps. We'll see you all next week. This is VK3EKH.
Yeah, cheers. Sweet dreams all. Yeah, VK3 AOB going that way.
Cheers, Brett. Audio. I think that's it. Yep. Okay. To everybody watching on the video, thank you for watching, and to Peter who's kept the repeater going for us. Thanks, Pete. You can turn it off now if you wish, and we'll see you. We'll do a broadcast, WIR broadcast this Sunday morning on 10:30 on RTV, and also on 160 meters at 9 o'clock. So if you want to listen to the broadcast at 9 o'clock while you're having breakfast, tune into the broadcast on 1825 kilohertz AM. And I'll be using my big emitter, which is behind me there. You can't quite see it in shot here. I usually have my second camera running here, but I've battery's gone flat, so I've been stuck on the one camera tonight. So thanks everybody for watching and viewing, and repeater's been hanging in there quite well, so I'm pleased about that. So we shall just go to our All Sky camera, and we'll fade away from there. So that's a live All Sky camera from Heathcote, and you can just make out a little bit of auroral glow in the south there, that slight pinkish glow in the sky. So there is still some activity going on. Exciting stuff, must admit, exciting stuff. All right, this is VK3EKH, ACO VK3CSJ concluding for tonight, and we'll be back to do it all again very soon. Where's my call sign? No, not that one. Not that one. Where's my call sign? There it is. That's me. All right, cross to the colour bars, and then we're out of here. Cheers, everyone.